I thank you all again. Over 100 attendees already on the line, 5 minutes in. We're so excited for the special program. I'd like to remind you all that as a member of the Netcapital team, I'm just here to be grateful for the great folks at Avadain who are actively raising capital on the platform. They're opening up this opportunity for where even you on the line right now can push button invest through the platform and own a piece of the Avadain company. We have two also particularly important panelists on the line. As I mentioned, we have Dr. Kevin Wyss and we have George Gilder. I'm going to do a couple quick housekeeping items, and then I'm going to dig right into the discussion that we have planned for you all today. So, as I mentioned, the Q&A feature in Zoom is fully active. Please go ahead and ask your questions there. There's going to be a dedicated section of the program for those specific questions. We also have a lot of programming queued up for specific things that people have already asked in the past. So we're going to make sure that we cover a lot of topics that people have already want to know, and we're going to make sure that we get a chance to cover your questions as well. So please do ask your questions. We're here for you. We want to keep this as interactive as possible. So that being said, I'm going to try to do a incredibly heartfelt and really thoughtful introduction for some of these folks. I could not go into their backgrounds in full detail, or else we'll use the entire hour. So we're just scratching the surface here. I'm going to start us off. Thank you so much for joining us, George Gilder. George Gilder is an American investor, writer, and economist. He's a technology futurist. He's the author of 19 books, including Wealth and Poverty, Knowledge and Power, and Life After Google. He's also co-founder of the Discovery Institute. George was a leading voice in the development of supply-side economics and famously advised President Reagan to back semiconductor chips. Very important. George was twice given a coveted buy recommendation to Avadain in his subscription newsletter, Gilder Private Reserve, and it looks like at least 1.5 million of Avadain's current raise on Netcapital comes as a result of this recommendation. So grateful to welcome George. So glad to have you on the line here. Thank you, George.
Great to be here. We're moving into a new carbon age, as momentous as the previous ages of steel and aluminum. Or even of silicon. It's a new set of 2D materials that weren't explained by the previous physics. Everybody predicted, or leading physicists predicted, that a single layer of graphite, like you use with your pencil, would just dissolve or break up into pieces, that you couldn't have a coherent graphene two-dimensional material at all. And it turns out that not only is it a 2D material, but that it's 200 times stronger than steel. It's perhaps 1,000 times more conductive than copper. It switches in the terahertz rather than the gigahertz like silicon. It is as flexible as rubber. It's got all kinds of incredible properties for a material that was believed to be impossible. So there have been 4 or 5 Nobel Prizes awarded for efforts to explain this as a topological material, a new kind of physics that more akin to Einsteinian physics, perhaps, than the usual quantum theory.
And we got to keep the audience on the hook here, because we can't give it all away this early. We're going to dig right into all of these incredible applications. You can see how incredibly enthusiastic George is about this application. So we're going to come right back to all that incredibly exciting stuff. And as we're talking about graphene's ability to transform thousands of products across 45 industries, we can't do that without having Dr. Kevin Wyss on the line here. So I'm super excited that we'll also hear from you. He's a PhD chemist and graphene expert who has authored over 35 peer-reviewed publications. He has deep expertise in nanomaterials, energy storage, and sustainable applications. Kevin did his PhD dissertation at Rice University on the flash Joule method of manufacturing graphene. And I believe that this is the technology that Universal Matter licensed from Rice to manufacture graphene nanoparticles. So Kevin specializes in graphene synthesis and chemical process engineering, helping to drive scalable solutions in both traditional and emerging industries. So grateful to have you on here, Dr. Kevin Wyss.
Happy to be here and work some with Avadain and talk about graphene in all forms. So
Thank you. Thank you. And last but certainly not least, of course, we have Brad Larschan here. He's the CEO of Avadain. He's an accomplished business leader and is expert in commercializing new technologies. He first began backing Avadain's graphene technology in 2016, and Brad will moderate the discussion and share insights into how Avadain is helping bring this revolutionary material to market. So thank you so much for being on the line with us today, Brad.
Well, thank you, Eric. And I really appreciate this opportunity to be here with the audience. I see so many names of existing investors, folks who have expressed an interest in investing, and they all have really one common thing. They really want to know about the true potential of graphene. That's why I'm so excited to be here with George and Kevin. I met both of them about 2 years ago at a panel discussion that George was putting together at the Discovery Institute at COSM. And I was absolutely blown away by the perspective that both of them have. So what I'd like to do today is start out with George and ask George to continue the remarks he was just making a moment ago, which is to try to put graphene in context for people. What does graphene mean to society? What is its potential to be transformative? George, the floor is yours.
Well, if you get a new material that entails a fundamental new physics, it offers a path to a real transformation of the entire economy. I mean, the entire economy was transformed by aluminum, by steel, aluminum, by silicon, and I've been writing about the silicon age for uh, 40 or 50 years now. I can't remember how many, but I started in the early 80s and I've been writing about the silicon age. And I believe that we're now at a point where we can move beyond silicon, that 2D materials offer all sorts of applications that transcend the capabilities of silicon. And so we have a new epoch, and and it enables uh, new applications like artificial intelligence that everybody's excited about. But artificial intelligence is nothing without its foundations in the the nanophysics that makes it possible. We now have Cerebrus has put 4 trillion transistors on a single wafer, and Tesla, Elon Musk has got these tiles that all actually uh, make possible technologies beyond anything in our data centers, which are kind of museums of old technology by some estimates.
Well, I think that's exactly right. I share that view. The the idea of having a new material opens up new industrial opportunities. So it really is a platform from which to build things, George. Which areas do you see as benefiting most immediately, that is in the short term, from graphene?
Well, there's the universal matter kind of applications where you use turbostratic graphene that has defects and is disordered to transform materials, to increase the strength of concrete by 30%, its tensile strength, its compressive strength by 20%. All these, and asphalt, they're already building roads in Britain with graphene suffused asphalt. And so there are advances already from this kind of graphene. Avadain, with its Fraunhofer exfoliation process is producing large scale defect free graphene, which is enables electronic applications, sensor applications, uh, you know, a variety of new uses, and which are more directly relevant to artificial intelligence. So that path is, and then there are, uh, at Georgia Tech, a more tentative development is wafer scale electronics, which Walter de here at Georgia Tech has been pioneering, where you have a whole wafer covered with graphene that switches in the terahertz and semiconducts. And that was a great breakthrough in a paper in Nature in early 2024. So there are lots of paths. I mean, it's a transformative material revolution comparable to steel and then silicon, and so it doesn't have single applications. It opens up a whole new cosmos of potentialities.
Great. Thank you, George.
Just to add
Kevin,
one more, energy
oh, please.
storage, batteries. We all know that wireless devices and wireless transportation, cars that plug into your wall and recharge require a lot of batteries. A lot of really stable batteries that charge fast, discharge fast, have a long life and stability. And so graphene has I think that's also one of the kind of earlier applications that we could see in the next few years is graphene being used in new batteries, new battery chemistries to really afford better energy storage for charging and discharge and overall stability and safety of the batteries as well.
And also thermal management, wouldn't you say, Kevin?
Yeah, safety. Yeah, exactly. Yeah.
Yeah, that's one of the early areas where you have batteries, for example, which have copper that typically would take the heat out of the inside of a battery to cool it so that you don't have a thermal runaway. And now we really see graphene, particularly high quality graphene, being a replacement for that and having an orders of magnitude improvement.
And thermal conductivity. Yep, you're exactly right, Brad.
Well, now that we've got you here on the hot seat, how about telling us a little bit about the different types of graphene and graphene materials?
Yeah, that's a great question. One that I get a lot because graphene is really a family of materials. And so you have different types, things that you make different ways. And so just like there are different grades of steel, like 3/16 stainless steel or 304 stainless steel, you use them for different applications. Some you would use as rebar and cement, and others you would use to make buildings, and other things still would be the stainless steel for your refrigerator. They have different price points. They're made with different ratios or properties of materials. And so these different types of steel have different applications. And graphene is very similar. So some types of graphene have known as graphene oxide have been chemically treated that give them this oxide layer. And so that can make them more soluble in water, for example, because the oxygen is going to interact with the water atoms, molecules. And so other types of graphene, like the type we're making at Avadain, is the large, thin, and defect-free graphene. And so hopefully we're making these extremely large compared to other nanomaterials sheets that are able to be used as true graphene. And so ideally you want your graphene to be one layer thick. You want it to be very large, maybe something you could hold in your hand if we were making it, but through chemical vapor deposition. But through the exfoliation, we get a much larger than nanoscale sheet size. And we're also looking for something that's defect free. And so just like a sheet of aluminum foil, you need the sheet to not have a bunch of holes in it, a bunch of wrinkles in it, a bunch of different atoms. You want it to be just one pure sheet of carbon to really unlock those amazing next generation material properties that George was talking about. Once you have even more than 10 layers stacked on top of each other, you lose a lot of those truly incredible electronic and quantum properties. So you really need to be less than 10 layers. And a lot of the graphene on the market today would be nanoplatelets. Those were kind of the first ones that were commercialized. They're relatively cheap and easy to make. These graphene nanoplatelets can be up to 100 layers or more stacked on top of each other. So of course you're not getting the best properties you could realize with graphene. And so there was a lot
That's
of
really
confusion, especially a few years ago, because people would call that graphene, and so people would buy that material and try and use it in their end application, and they'd say, "Oh, it didn't change everything," but that's because they weren't really working with graphene. They're working with these many stacked nanoplatelets. So graphene materials, they should be selected based on what the end use is going to be, what application you're going to use, and what properties you need. And just like different types of steel, some very high value applications exist where you need the top of the line. And so then you need to use these large, thin, and defect-free graphene powders that Avadain is making.
I would say, Kevin, that you've really put your finger on the biggest commercial challenge I think Avadain faces, and that is that end users really don't understand that there is no one thing known as graphene, that it's really a continuum of materials. I remember when we first started talking to people in the Defense Department, they thought graphene was all hype and no delivery because they had used it in bulletproof vests for ballistic armor, and they found that it was brittle. And it's taken years to try to explain the difference between like a graphene oxide in performance, or graphene or graphite nanoplatelets in performance versus the large, thin, and defect-free graphene. George, is there anything you wanted to add to that discussion that Kevin has
well, it's
just?
just according. It's you, the essence of technological progress is surprise. And Avadain produced surprises, and I'm down in Houston with MTM Corporation, and they're producing other surprises using flash jewel heating to uh, secrete rare earths from red mud or electronic waste. And Jim Tor, my guide and who introduced me to graphene, you know, uh, cash from trash in a flash uh, is one path, but there are also these very ambitious wafer scale graphene uh, projects, and they're all Avadain, a cornucopia of applications for pure defect-free graphene. It's it's a whole new array of opportunities that's going to shape a new carbon era.
Yes, I think that's right. We like to say that we really are on the precipice, or we are already into the graphene revolution. Um, Eric, is there anything you wanted to say at this point?
Yeah, I'd love to take this moment to, again, I'm appreciating the very thoughtful discussion from the panelists. I'm loving the questions coming in from the audience here. Please continue to add your questions. We have the time dedicated for that, so don't worry, I haven't missed you. If I look unfocused, it's because I'm trying to make sure I keep all those ready for Q&A. And I'd like to remind you all that in the chat feature, I added a link to the offering page where you can review a lot of materials about Avadain. You can review, and if you're so inclined, you can invest directly through the portal there. If that's not showing up for you, you can go directly to netcapital.com/companies/Avadain. You can also go to netcapital.com and search Avadain. Very simple. And you can invest debit card, credit card, ACH, wire transfer. I see somebody on the line here saying they participated in every round of Avadain's offering. That makes me really excited. So I continue to please use the Q&A. We're going to get to as many of those as possible. So I'm just loving seeing the interaction that we're having from over 100 of you in the audience right now.
Yeah, it's very gratifying, and I've seen, looking at the attendees, many many investors who have invested in every round. So thanks to them. And Eric, I don't know if you know this, but we're now at over $9.27 million. 4.927 million. Sorry. So we're near the 5 million cap. It's really it's very humbling for me to have seen the performance on this. But I'd come back to the panel discussion and 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 ask George how he sees graphene moving forward commercially. Um, do you see any trends out there yet, George?
Well, I think the first trends are as an additive to change the properties of other materials like concrete and asphalt, and uh, but there are also electronic applications. The first most popular ones, which already have momentum and markets, are sensor applications. There's in Europe, there's a company called Paragraph that has innovated with sensor applications, and Graphene is another one. And they're just, it's, China is rushing ahead uh, for what it's worth. And because the FBI wants to drive Chinese students out of the United States. So they go back to China and get lavished with venture capital for graphene um, startups. So, that it's just happening across the economy, and it's the new epoch, and these new epochs provide lots of opportunities for innovation, as Avadain is both enabling and discovering itself.
I think, yeah, I see that as well. The For me, the focus of the Chinese typically has been graphene oxide because they were very early in focusing on that. Did you have anything you wanted to talk about with that, Kevin? About
Yeah, definitely.
um,
And you're totally right that graphene oxide has been, I think, was able to be scaled up. Graphene oxide and graphene nanoplatelets were both pretty early, low quality versions of the graphene material that were able to be scaled up and able to be sold at scale. And so even that has only been going on maybe for four to 5 years. One of the first major industrial adopters of graphene in a product was Ford Motor Company. So I love to tell people that graphene could be in your driveway right now. But they were using those 100 layer stacks of nanoplatelets just as an additive into some of their plastics. And even that low quality of graphene family and at very low additive amounts, they still saw some really great improvements in strength and noise absorption, heat absorption, things like that, stability of the plastics. So that was only about 4 years ago that Ford started rolling that out. So we're really and that's using the low quality types of materials. And so as we start to get better at producing the really high quality materials like Avadain is doing, where you have these larger sheets that are able to be even stronger, even more conductive, you're able to use even less of them. They have some of those amazing quantum and physical properties that, once you get to the more than 10 layers, you lose those. But, with Avadain, we're still able to keep those. And then the lack of defects also makes them stronger and more conductive. And so once we're able to scale up the really high quality graphene materials in the family, then we're going to have something that kind of its own cycle of supply and demand. And so I like to think back to aluminum. Aluminum was a really valuable material. It was so valuable that they capped the top of the Lincoln Memorial with it because it was so valuable, almost as valuable as gold for a long time, until someone discovered a new way of making aluminum, pure aluminum. And now it's got used from everything to cans to airplanes and everything in between. And people say that the Wright brothers had aluminum not been invented because aluminum is so light and strong. they probably wouldn't have been able to make the engine for the first airplane without aluminum. And so it took, someone figuring out a new way to make aluminum so that they could buy it at a low price so that they could make the first airplane. So that's kind of the circle of supply and demand I see. Once you're able to make a really high quality material at scale, then the users and end users and applications will definitely appear. And then you get the cycle of supply and demand. And then you got to obviously work with the applications to develop and optimize how they're using graphene in their applications and end uses. So
Yeah, graphene, it really irritates me when I hear venture capitalists talking about, what is the killer app for graphene? Because really what it is that they've completely missed the boat on graphene. They're thinking, okay, you're going to manufacture graphene, but you really need to manufacture one product with that graphene. Rather than seeing what George and Kevin are talking about, which is this being a transformative material that opens up a whole new age of a new industrial revolution, if you will, enabling hundreds and thousands of products to be used. And because of that, what we're seeing is for the low quality materials where they were able uh, to identify a product like building roads with graphene. Now there's just an abundance of supply of those materials, but there's not enough customers for it. And then on the other hand, with LTDF graphene, what we're seeing is that there are many, many companies that want to utilize it, but we don't have the supply yet. And so that's really the challenge right now for us is to shift that paradigm and get that production really increasing. Um, and in that respect, I just wanted to ask, maybe we'll start with Kevin this time, how you see graphene aligning with the Trump administration's new priorities.
yeah, certainly. And we touched on it a little bit earlier that China and other Russia especially have been looking a lot at they were kind of early adopters of graphene, particularly graphene oxide. And they really scaled a lot of that and a lot of the current national supply or international global supply of graphene oxide and graphene nanoplatelets really come from China and Russia. And so you obviously want to domestic production of these super materials, but going a step further and instead of looking at graphene oxide, a lower quality type of material, we can look at the large thin defect free graphene that we can license to American chemical producers and things like that, and kind of build our own domestic IP end user database basically. And so I think that, obviously, with some of the trade and tariff things lately, you obviously need domestic production. It's clearly a very large push for the current administration, as well as thinking about optimizing our defense strategy, and then also going towards graphene being able to allow lightweighting in things like drones, and also better batteries and charging for really any type of wireless or drone. And then lastly, shipbuilding. And I know Avadain is working with the Navy postdoctoral research school to do some studies on how can the large thin defect free graphene work with some of the aluminum for shipbuilding and things like that. And that's not even to touch on the AI and semiconductors that George was earlier, where we need better, faster processing computers, better heat management, better energy efficiency in a lot of these AI data centers. And graphene is really positioned to tackle a lot of these really important national problems.
So, George, you've been around the block quite a bit. What uses for graphene can you see that align with what the Trump administration is trying to do, or what the Trump administration should be trying to do?
You know, I'm not particularly interested, to the extent the politicians try to govern the future of graphene, that future disappears. Uh, these new technologies, these frontier technologies, are created by geniuses, and they're distributed all around the world. And any effort to sort of cut off the US from the world and monopolize graphene by some sort of nationalist project will in fact stifle the future and uh, and weaken American capabilities. So I think you know, Trump is all about the art of the deal, and there's a lot of noise out there, and it's hard to tell precisely what the purpose of a negotiating bluff might be. But I think the tariff, you know, that because tariffs really are obstructive to the future rather than they're they're only usable as threats and tools. And so I don't pay any attention to them. I think that a year from now, we're going to see a completely different um, environment. And to the extent that it becomes sort of efforts to depict the U.S. as somehow a victim of the world economy. I mean, that's obviously political bunkum. I mean, we have 70% of global market cap for our corporations. China has about 8%. You know, it's just ridiculous to say that China's ripping us off, and you know, all this is they're now China is becoming a defender of patents now. They got more patents generated than we do, and it's I know that Xi is posturing as a new style communist, but and is trying to repress the citizens of China, but we shouldn't help him by you know uh, tariffs and other kinds of needlessly antagonistic postures. Uh, it, but again, I see Trump as the art of the deal, and I'm going to wait to see what the deal actually turns out to be. And I hope it opens up new opportunities for graphene for this new carbon age that I see coming.
Well,
And
I think
Trump, unlike the previous administrations, at least understands that carbon isn't a pollutant or a disease, that it's crucial to life and all our prospects as human beings.
and a brighter future. To me, I see graphene aligning with this new economy in the United States in a few ways. First, I think that with energy storage, which Kevin talked about, you know, the carbon transformation for battery electrodes giving higher energy density, faster charging, faster discharging, and longer life cycles. I think that's really important. I also believe that in the area of semiconductors, that graphene is going to make a big difference. It might take a little while to get there, but graphene being used for electrical interconnects can significantly cut down heat that are being produced in data centers, particularly AI data centers. As you've pointed out before, George, in GPR, it takes as much electricity to cool an AI data center as it does for computing. And a big function of that is that the electrical interconnects are made of copper and silver. And as you talked about in your introductory remarks, graphene is a really great conductor. It's almost a naturally perfect conductor compared to these metals. And so we see that as a way that maybe graphene can align in shipbuilding. Kevin touched upon integrating graphene into the materials that comprise the hull of the ship, but also the coatings of the ship, very
Uh,
importantly, to
yeah.
prevent corrosion and all of that. Um, well, I could go on and on about that. And as you can see, there's no lack of enthusiasm among the panelists. But maybe, Eric, it's time for us to address one or two questions that people might have.
That's fantastic. Yeah, great job. Thank you so much. There are two things that I'm so grateful for in having this role with Net Capital. The first one is meeting fantastic folks like the panelists on the line here. and I'm tempted to get my way out to Houston to hang out with a couple of y'all. And the second part is learning incredibly exciting things. This is an area that I otherwise would not be as familiar, and I'm very grateful for Brad to bring this to my attention. Because as a technologist myself, I'm really grateful to learn some of these things. And so let's continue the learning by answering some of these questions here. There are dozens of them, so please bear with me. We're trying to keep some of the responses relatively brief so we can get to as many of them as possible. And actually, before I get into the questions, might as well remind you all that Avadain is actively raising capital on the Netcapital platform. You can go to netcapital.com/companies/Avadain, where you can invest and become part of the family here. So to start us off, what are the graphene production limits to scaling up to meet commercial demand?
Yeah, so again, that depends
no,
on the type of the material, but in terms of what Avadain is hoping to produce, I I can speak from kind of the demand side, being kind of the application side, and having worked with graphene for so long, that the demand would be extremely high in terms of all these different applications that we're looking at. And of course, I mean, you're going to go through a prototyping phase and a feeling out phase once you enter into, say, a joint venture with someone, or you start selling someone the material, or one of your licensees starts selling the material. They're going to have to go through a few cycles of prototyping to optimize the end use application. But everything from definitely composites, some of these high value, heat and sensors. I think those are pretty near term. Batteries do take, I'd say, a longer time worth of prototyping, but would be a very high volume and relatively stable market. But I'd say definitely composites, coatings, inks, and then heat dissipants would definitely be extremely in demand for the LTDF material.
Yeah. And I imagine you guys all have a lot of thoughts on a lot of these, but I feel like that was pretty comprehensive. So I think I go to the next question just to make sure we get to as many of these as possible. Um, can you comment, okay, cool. Can you comment on some European companies using what they call tubular graphene to greatly improve supercapacitors? Is there anybody that feels comfortable handling that question?
well, I think Zeta, Zeta, one of Jim Torr's companies, actually cited in Israel, uh, uses graphene for supercapacitors and battery enhancements. But I don't know whether Israel is part of Europe anymore or not. But in any case, it's Israel is a center of graphene innovation. And that Zeta is one of the companies that is pioneering this particular use.
Kevin, when I hear the word tubular, I'm thinking carbon nanotubes.
Yep. Yeah. I agree. That's probably carbon nanotubes, and there is a good bit of overlap. And I think I saw another question in the Q&A about carbon nanotubes. There's a lot of overlap between carbon nanotubes and graphene. Basically, carbon nanotubes are just a rolled up sheet of graphene. And
Yeah.
so you get a lot of the similar conductivity and strength. You don't really see, because it's not a nice sheet, you don't see a lot of the use in sensors or electronic applications or things like that. And then also, because of the tubular formation, you can get it's a more carcinogenic and harmful material to humans. If you think about asbestos, those are those really long, thin fibers, kind of like what carbon nanotubes are like. So carbon nanotubes were also, they kind of had a head start of about 15 to 20 years on graphene. And so they were kind of discovered first. They had a lot of some of the really interesting properties, but I think graphene has more applications, has better properties, and then also doesn't have the health risks associated with carbon nanotubes.
Right. When I think of not carbon nanotubes, I think of a material whose time has passed, because for the most part, graphene has come forward and has more advantages and less, well, really no disadvantages.
Mhm.
And so, I think of tubular as being, sort of, 10 years or 15 years ago technology.
Well, they believed that was the ultimate form of carbon. That was the most stable form of carbon. And it turned out that this was a mistake in physics, that the most stable form of carbon is, in fact, graphene. And so this is really the revolution that opened up the path forward for companies such as Avadain, a pioneer in this area.
That's super helpful. Thank you so much. And the nanotubes, that helped me understand a lot better about that. A couple more really great questions. Going back to the business case for a moment, I know there are several licenses. About how long are these licenses generally for when you grant licenses to people to use your technology?
So that's a great question. And in fact, I don't think we've talked enough about this. So thank you, Eric. I really appreciate that. So there are really two types of licenses. One is for manufacturers of our graphene, and these would typically be chemical companies or advanced materials companies, companies that are used to making materials and have the plant, the equipment, the people, the expertise, the regulatory framework, and most importantly, the customers. And so those are perpetual for the life of the patents. And so, that those licenses last as long as our patents last. And if I have anything to do with it, that will be a good long time. Um, so, so manufacturing licenses are perpetual. On the other hand, we have end use licenses. Because the supply of graphene is limited, we want to make sure that we identify really rock solid companies to be able to implement the LTDF graphene in their end products. And those are exclusive licenses for a defined period of time, say like 5 years. After that, it converts to a non-exclusive license, and then all of their competitors can come in. And in that way, we can grow the penetration of graphene, but it then takes on a life of its own when it becomes freely available for all companies in a specific field of use.
No, no, thank you. And I do feel like that was something that I wanted to make sure we covered because that is really interesting. I think that's very important for investors to understand from the business standpoint. Now, right back to some really fun applications. I've seen more than a couple people reference a space elevator, so we have to talk about it. People are saying I've seen conversations about a space elevator using graphene. Please share your thoughts on this application.
That,
George?
yeah.
I don't know. It's a metaphor. Um, and graphene does indeed offer a path to outer space. I mean, lighter, more enduring, much more rapidly switching, more conductive technologies, in fact, do offer a path to outer space. And whether it's a space elevator or some sort of magical ladder, or maybe some application that Elon Musk launches for Tesla, it's going to be it's a ladder to the future, and so I like it allegorically, but I don't know about whether just what you envisage as a space elevator.
Right. Yeah. I'm with George here. Think of it as a way to reach the stars, right? Rockets, spacecraft that can be have graphene integrated into their materials to make them lighter and stronger, to be impenetrable to solar flares from radiation, that sort of thing. And so it's a material that can take us to the stars, not 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 physically in the sense of getting on an elevator and going to the moon or something like that, but rather building aircraft, building rocket ships and habitats on different planets.
I'll tell you, I think myself and some others on the line, May the 4th just passed, and we're disappointed that there might not be a literal space elevator anytime soon
Oh
up to
gosh.
ISS. But let's continue. Let's continue along here. And there's a couple questions that I'm going to try to combine here. So can you talk about anticipated roadmap and timeline for commercialization? Excuse me. And I know you've talked on some of these subjects, but maybe we'll elaborate just a little bit more. What market areas do you see as the first focus areas for Avadain? expected timeframes for first commercial uses. You mentioned production capacity as being one of the impediments for commercialization. What are some other challenges or crucial to overcome to get to commercialization? So, kind of a big, broad timeline and thoughts about applications towards commercialization.
Sure. The first thing I would remind everyone is that we are licensing to manufacturers. It's the responsibility of the manufacturers then to prioritize their sales of graphene to their customers. And so each manufacturer will be in different areas so that they're not competitive in the sense of going after the same customers, but rather growing the penetration of graphene in composites, in metals, in electronics, in heat conductivity, in all of these different areas. So each manufacturer will do that. Harcross Chemicals is our first licensed manufacturer. And I certainly am not going to give away their customer list, but they have more demand than they'll be able to produce for years for graphene. And that leads to the second part of the question, Eric, and that is, what are the impediments? To me, and I'd like Kevin's thoughts on this as well when I'm done, but to me, the impediment is to look at how we can streamline the process of scaling. The Graphene Council, which is the trade association, the International Trade Association for Graphene, said that they believe that in between 2030, 2035, the demand for high quality graphene like we're producing would be somewhere between 30,000 and 90,000 metric tons per year. That's a projection. We're talking about 2 metric tons capacity per production plant, right? So the way I lose sleep is I'm trying to figure out how we go from 2 metric tons capacity to tens of thousands of metric tons of production to meet that demand. So to me, that's what the impediment we have to overcome is. Kevin, you're intimately involved in this. Did you want to add anything?
Yeah, I think that's a good point. And I mean, definitely any translational technology going from like a technology institute like Fraunhofer into an end use application. Scaling is, I'd say, the hardest thing to do, scaling it at cost and scaling it to keep your initial properties. But one of the great things about graphene is that you're able to use, especially in things like composites, inks, sensors, you're able to use so little of it. You're able to use one thousandth of a one thousandth weight percent. So you're able to. That's what Ford was using a lower quality graphene nanoplatelets. They were using 0.1%, so one thousandth weight wise, to greatly improve their plastics and things like that in your car. And so, because you only have to use such a small fraction of a percent to realize these great applications, a little goes a really long way. And working with some of Avadain's material, the surface areas that they're getting and the increase in volume during production is really pretty amazing. So yes, scaling is difficult, and it is for most things. But the great thing about graphene is how long a ways just a little bit of material goes. So
Yeah, that's really important. Thanks for sharing that. And
That's
I love
that's
that you.
what That's one point, but the fact is that it's scaling massively all over the place, including at Avadain. And I just think one of the signs to me that we're entering a new material era is how rapidly it's scaling. I mean, from the time it began at Torr's laboratory at Rice, Dr. Jim Torr at Rice, where I'm visiting, to today, it's many thousandfold in 5 years. And it's scaling all over the place, I can tell you. And I just that's why it's so immensely promising because it does scale. And as things scale, they become cheaper. And as they become cheaper, generate more uses and more demand. Supply creates its own demand. So this is Say's law, and Say's law is certainly at work in this new cornucopian material.
Yeah, no, thank you so much for adding that, George. And Dr. Wyss, I'm super grateful that you shared about the Ford example. I think that's so fun and how full circle for you, Brad, to have been able to bring on recently Henry Ford III onto the board of directors. I think that's really cool experience there. And Ford is known for some pretty successful patent execution. And you're trying to rival that patent portfolio with I think about 58 granted patents in this space already. So I think those two pieces are getting me really excited about the opportunity here. We're getting down to the last few minutes, so I'm going to speak a little bit uncomfortably quickly here. But is there any data on the effect of radiation on LTDF graphene? Can we sneak
I was
that one
actually
in?
just typing an answer to that in the chat, and graphene
Okay.
is really good at absorbing electromagnetic radiation. So things like if there's a EMP, for example, that's kind of the new age of warfare, possibly, where people are trying to take down other people's electronics or energy grids. So putting a little bit of graphene into plastics or metals or things like that can give you shielding. And so that has, obviously domestic and defense applications as well as energy grid applications. And then thinking more like I think Brad mentioned earlier, is space or satellite applications where you have these solar storms and things like that. Graphene is really good, very, very good at EMI shielding. It's so.
Super cool. And I think this will probably be my last one. I'm going to combine two. Can you talk a little bit about your progress towards producing a module? And then how does that set you up in terms of timeline for a potential exit? Now, I'm going to insert a piece here. We always say the future is inherently speculative and uncertain. So, with that massive caveat, can you tell us a little bit about kind of exit strategies and timelines to producing some of these tangible assets?
Sure. We are currently building, well, let me step back for a second. So our technology is different than most other graphene producers because we want to have widely distributed production. We think that graphene should be produced near where the large end users are. And there are a lot of reasons for that, but I won't go into that today. We don't have enough time. So we've designed from the beginning a modular reactor so that you can add the modules in order to increase the production capacity. And so we've designed through our partners at Southwest Research Institute. Kevin's been involved in this. Phil Van Wormer on our team's been involved in it. A modular reactor that can produce graphene. We're now building that into a pilot plant for Harcross Chemicals. In September, we're going to ship that pilot plant to Harcross to demonstrate the quality and capacity of the graphene that we're producing. Then we add those modules into series in order to create greater supply. And so that is a very cost-effective way to have production. And more importantly, I think, is that the production can therefore be disseminated throughout the United States and even indeed throughout the world, close to where the graphene needs to be utilized.
I think that was perfectly said. I think it was perfectly said. I see people referencing how close Avadain is to the maximum raise permitted under this offering. I do know, there's no certainty, and I won't express any specifics about any potential future financings, but there is some technology built in to where we make sure that we keep track of anybody who's unable to participate in this offering. I know some folks were on the wait list in the past offerings, were able to participate in future offerings. So I do make sure to keep track with us. We have some great folks on our investor relations team to ensure that if there's an opportunity to make that available to as many folks online here as possible.